Hey, happy people, this is Mr. Wilcox coming to you from my kitchen table. So in Algebra 2, we just finished up looking at a little bit at sequences and series, and then we looked at reducing radicals, and the reason we looked at reducing radicals is that so we can review some trig functions. We're going to review sine, cosine, and tangent. And then after this day, we're going to talk about the unit circle and how sine, cosine, and tangent fit in there. That's going to be basically the rest of our year. So today we're just going to review how to do trig with right triangles. So basically how we find the exact values for sine, cosine, and tangent. So before we talk about SOHCAHTOA and sine, cosine, and tangent, we're going to quick review what the Pythagorean theorem is. So I'm going to pause here so you can pause the video and write this in your notebook. And when you're ready, hit play again. So Pythagorean's theorem states that the sum of the square of the legs of a right triangle equal the square of the hypotenuse. The hypotenuse is always our longest side across from the right angle, so it's always C. And then we name the legs A and B. So you might remember Pythagorean theorem from geometry as a triangle with a right triangle with a squared plus b squared equals c squared. Just always making sure that A and B are our legs, and C is always across from that right angle, being our longest side. And so we're going to use that today to find the third side of a right triangle. And here's what the other thing we're reviewing today is what the word SOHCAHTOA means. And so I'm going to pause here so you can write these trig functions in your notebook. When you are ready, you can pause the video and hit play again. So these are the three first trig functions we talk about. They are sine, cosine, and tangent. There are three reciprocal functions, but we will not get to those this year. So because they are functions, you have to take the sine of something, the cosine of something, and the tangent of something. So you have to have something after your sin, something after your cos. Tan, if you see this little mark, it is the Greek letter theta. So the Greek letter theta is what we put in as a variable to stand for angles usually. So to find the sine of theta, we're going to take and we're going to find the ratio of the opposite side to the hypotenuse. So what's going to happen today, you're going to have a right triangle and you're going to be given an angle that is not the right angle. So it's either going to be down here like it's pictured on this triangle, or it's going to be the other side up here. It doesn't matter where it's placed. So opposite side means the side away from the angle. So the side that doesn't make up the angle at all. So the side farther away. So opposite. Adjacent means next to. So that is the side that is next to the angle or helps make up the angle. And hypotenuse is the longest side that's always across from the right angle. So our opposite and adjacent sides do change based on where we place our angle. And so since our angle is placed in this corner, our far away side, our opposite side, is the short side this time, and adjacent is the long side. So if we were going to try to find the exact values for sine, cosine, and tangent, for sine, we would take the opposite over the hypotenuse and simplify that ratio. For the cosine of theta, we would take the adjacent side over the hypotenuse and simplify that ratio. And for tangent, we would take the opposite side over the adjacent side and simplify that ratio. And the word that helps us out so much with this is SOHCAHTOA, because you can see sine, opposite, and hypotenuse, cosine, adjacent, and hypotenuse. Tangent is opposite over adjacent. So the word SOHCAHTOA is a great thing to memorize to help you with trig functions. So let's do an example to make sure we understand that. So what's going to happen today, you're going to be given a triangle with two of the sides given to you, and you're going to have to find the exact function for the exact values for sine, cosine, and the tangent function. So go ahead and write this down. When you may want to pause the video so you have enough time. When you're ready, hit play again. So, in order to find this exact trig values, you need the value for each side. And so that's where the Pythagorean theorem comes in, because in this case, we are missing our we're missing our hypotenuse. So if we set up an equation where we take 6 squared plus 8 squared and set it equal to c squared, we can figure out what our c is. So if we take 6 squared plus 8 squared, we get 100. And then in order to find what c is, since c is squared, we can square root both sides and take the positive answer because it wouldn't make sense to have a negative side length. So in this case, we are going to have a c of 10. All right. So now that we have the lengths of all third sides, let's go through and label each side as it is related to our angle. So our angle theta is down here. So 8 is the angle that is far away, or our opposite side. 6 is the side that touches our angle, so it is our adjacent. And C is our hypotenuse. All right. So we're going to use the word SOHCAHTOA to find the exact values for sine, cosine, and tangent. So for our sine of theta, so remember it's a function. You need to write the sine and then of something. So we're taking the sine of theta. We're going to take our opposite side, which is 8, and put it over our hypotenuse, which is 10. And then if we need to simplify. In this case, that simplifies to 4/5. Right? For cosine, remember to write the cosine of theta because it is a function. So it's important we know cosine of what. Cosine of theta, we're going to take our adjacent side, which is 6, and put it over our hypotenuse, which is 10. And then see if it can be simplified, which this can be, to 3/5. All right. And finally, for tangent of theta, we're going to take our opposite side 8 and put it over our adjacent side 6 and see if we can simplify that. And we can, to 4/3. So remember, this is a ratio. So you're going to write it as an improper fraction. Never ever write the answer to a sine, cosine, or tangent function as a mixed number. So if you had 1 1/3 there, that'd be wrong. So make sure you have 4/3, not 1 1/3. All right. So again, find the third side using the Pythagorean theorem. Find your ratios and simplify. We're going to have one more example for you. If you need to pause the video to write it down, go ahead. I'll stop for a second so you can do that. And when you're ready, hit play. All right, I wanted to do one more example that had a side that was a root, just to remind you that we are looking for exact answers. And so we don't want to estimate any of our square roots to decimal points. That's why we worked with reducing radicals to begin with, was that so we knew how to give answers as reduced radicals. So we're missing a side here. It doesn't matter if you label it A or B. I'm just going to label it B. So if I take my 1 squared plus my b squared, that should equal square root of 5 squared. And how did I know how to set that up? Well, remember, your hypotenuse is always across from your right angle. So our c here is the square root of 5, and one of our a's is b, or one of our a's is 1, and we don't know our b. So if we simplify, we'll get b squared equals, and this is 5 minus 1, so we'll get b squared equals 4. And if we use our square roots to solve, we'll get b equals 2. I'm sorry. For some reason, my pen doesn't want to write a 2 right there. There we go. 2. So now we have the length of each of our legs and our hypotenuse. So our legs are 1 and 2, and our hypotenuse is the square root of 5. So remember, we want to use SOHCAHTOA. So I'm going to go through and label my sides so that it is helpful in order to use SOHCAHTOA. So our theta is right down here. So if our theta is down here, the side that is opposite that or across from it is our 2. This is our opposite side. Our 1 touches our angle, so it's next to our angle or adjacent. And across from our right angle is our hypotenuse or square root of 5. So what we're going to do is we are going to go through and find the exact values for sine, cosine, and tangent and make sure they are in simplified form. So for sine of theta, we have our opposite side 2 over our hypotenuse, the square root of 5. Now remember when we were reducing radicals, we said you can never have a radical in the bottom of a fraction, and that is still true. And how we got rid of that is we multiplied by that radical, because if I take the square root of anything and multiply it by itself, that is essentially squaring it, getting rid of the radical. So I'm going to multiply by the square root of 5 on both top and bottom, so that I'm multiplying by the number 1. And if I do that, I'm going to get 2 square roots of 5 over 5. So last thing, can I simplify 2 square roots of 5 over 5? I cannot, because 2 and 5 are not reducible. And remember, you can never reduce a number inside a radical by a number outside a radical. So you cannot take the 5 inside this radical and divide it by the 5 outside. So 2 square roots of 5 over 5 is the simplest answer for my sine of theta. Cosine theta, I'm going to take my adjacent side 1 over the square root of 5. Again, I have a square root of 5 on the bottom, so I got to multiply by square root of 5 on top and by square root of 5 on bottom. So I'm multiplying by the greatest number in all of algebra, which is 1. And so I will get the square root of 5 over 5. And again, we can't reduce a number inside a radical by a number outside a radical. So square root of 5 over 5 is the most simple answer we can have for cosine of theta. And finally, for tangent of theta, I'm going to take my opposite side, which is 2, over my adjacent side, which is 1. And if we simplify that, that's just the number 2. All right. So again, today you're just going to find your third side by using the Pythagorean theorem. And then to find the sine, take the opposite side over the hypotenuse. To find the cosine, take the adjacent side over the hypotenuse. And find the tangent, take the opposite over the adjacent. And just make sure that your fractions are as simplest form, whether that be taking 4 over 8 and making it 1/2, or making sure there's no square roots on the bottom. So I hope you are happy, I hope you're healthy, and I hope you have a great day.